Okay, we're going to look at madasq question 6, which is looking at the binomial distribution. So we've got x is distributed binomially 15 appointments, probability of 0.15. So the first part of the question asks us to find the probability that exactly 2 patients will fail to turn up. We can do that directly through the binomial distribution here. So because it's x equals to 2, I'm going to use the binomial probability distribution, and here I'm going to use variable. I know that x equals 2, n equals 15, p equals 0.15, and that's where I get my answer of 0.286. Then it's asking me for the probability that at least 2 patients will fail to turn up. It's the probability that x is greater than or equal to 2. Remember, I'm always looking at the left-hand side of the distribution, so it always needs to be x is less than or equal to something. So probability x is greater than or equal to is the converse of x is less than or equal to 1. So 1 minus the probability that x is less than or equal to 1. Again, going to my binomial, and this time cumulative distribution because it's an inequality. I'm looking at a variable. I've got probability that x is less than or equal to 1, so I need to change that over to a 1. And it gives me 0.319. 1 take away 0.319 gives me 0.681. Part B is asking us to use a normal approximation to the mean. Page 13 of the formula booklet gives you the information you need to do this. So it tells you the binomial distribution, the mean equals NP, and the variance equals NP 1 minus P. Now, in this case we know that x is distributed binomially 400 appointments and a probability of 0.15. So we can approximate this with a normal distribution, which is y is distributed normally with a mean of NP, so 400 times 0.15, and a variance of 400 times 0.15 times 0.85. Remember, that's the variance. I need to square root it to find the standard deviation. So I'm just going to put it like that just to remind myself that I'm going to need to square root it when I want to do something with it. So that then tells me that y is distributed normally 60 root 51 squared. Now, in the question it says, find the probability that x is greater than 45. Be careful of the language here, it's strictly more than 45, but at most 65, so less than or equal to 65. Now, if x has got to be greater than 45, I'm going to now do a continuity correction when I'm looking at my normal distribution. So here's my normal distribution, and I'm looking at y. So I want to make sure that whatever number I choose for y is the lowest number that does not round down to, does not include 45. So it's going to be 45.5. Here, if I think there's my 45, there's my 46, this point here, that's the lowest value that does not round down to 45. So here, I'm going to have 45.5. I want to go up to the largest value, because it's included the largest value that does round down to 65, and it's going to be down here, so y is less than or equal to 65.5, and that's called my continuity correction, because remember that the normal distribution is continuous, whereas the binomial distribution is discrete. Once I've done that, I can go straight onto my calculator, so I'm going to go onto menu option 7 for my normal cumulative distribution. My lower bound is 45.5, my upper bound is 65.5. My standard deviation is the square root of 51, and my mean is 60. And it gives me a probability of 0.758. It's not part of the question, but just in case you're interested, if I'd used the actual binomial distribution instead, the probability that x is less than or equal to 65 on the binomial distribution was 0.7813. Probability that x is less than or equal to 45 was 0.0183. If I subtract those, you should be able to see it's going to give me an answer of about 0.77, which is pretty close to what I got by approximating it with the normal distribution. So part C now is asking us to do a hypothesis test using critical regions. So let's have a look. We know that n equals 20 and p equals 0.15, and we're looking for a significance level equals 5% because it's a two-tailed test, so we're looking at two tails. So we're looking on the left-hand side for a probability value of less than 0.05, and on the right-hand side we're going to be looking for a probability of less than 0.95. So let's have a look at our tables. Hopefully you can see that here. This third column here is my 0.15 table. Apologies for that. That's my 0.15 table. If we have a look down here, the probability, there's only one value here which is less than 0.05, which is my first value. So let's just write that down. Probability that x is less than or equal to 0 equals 0.0388. On the upper end, probability that x is less than or equal to, well, we're on this table here, so I'm looking for those values which are closest to 0.95. So let's write down probability that x is less than or equal to 5 is 0.9327. And the probability that x is less than or equal to 6 equals 0.9781. So we're now going to use this to work out the probability that the converse of x is less than or equal to 5 is the probability that x is greater than or equal to 6, which is 1 minus 0.9327. That's going to give me 0.0673, which is 6.73%. So if we're trying to keep our values in our tails less than 5%, then we wouldn't choose to reject x is greater than or equal to 6. So let's have a look now at x is greater than or equal to 7, which is 0.9781. 1 minus 0.9781 gives me an answer of 0.0219, which is 2.19%. So I've got 3.88% on my left hand side, 2.19% on my right hand side. So my critical region is that x equals 0, because that's the only way that x can be less than or equal to 0, it can't be negative, or x is greater than or equal to 7. Now, it then asked me for part D, what would the change be if you were looking instead for the probability in each tail being as close as possible to 5% rather than less than 5%. Here, we would, rather than using this one, which is roughly 3% away from 5, you'd use this one, which is 1.73%, so the critical region would then become x equals 0, union x is greater than or equal to 6. Notice I haven't changed my my value at the bottom end purely because the probability that x was less than or equal to 1 would have given you 17.56%. I'll just write that in up here just for the sake of clarity. Probability that x is greater than or equal to 1. (17.56%), which is just way off. So you're not going to use that ever as your tail.